Hello, this is Nicholas Vineman from Silicon Chip Publications, and today I'd like to talk to you about this new project that you can build a digital preamplifier and crossover, which is one of the most advanced projects that we publish in Silicon Chip magazine. And don't let the August 2025 date at the bottom fool you. This is an early draft. It was actually published in our October 2025 issue, and since it's three parts, it will also be in the November and December 2025 issues. So let's just have another look at this, because I only went through it quickly last time. So the interesting thing about this is that it is a preamplifier that has analog and digital inputs and analog and digital outputs, but pretty much everything is done digitally. So the analog inputs, if we look at the circuit here, these relays select one of the inputs. You just choose which one you want. It buffers them and it sends them straight to an analog to digital converter, which is here, which digitizes the two audio channels and sends them to a DSP. And the DSP means digital signal processor. Here it is. And it gets the ADC data in these pins here. And it does processing, and that processing can include changing the volume, adjusting the tone balance, so you bass boost or cut, treble boost or cut mid-range, all that sort of thing. And because it has the ability to apply filters, that means it can be used as a crossover. In other words, if you have three-way speakers that have woofer, mid-range, and tweeter drivers, traditionally you'd have single input, just two wires going into the speaker, plus or minus, and you'd have an internal crossover that would split the frequencies in the signal into low, mid, and high, and then the low frequencies would go to the woofer, mid would go to the mid-range driver, and high would go to the tweeter. Trouble with that is that analog crossovers have to handle the full power. So if it's a 100-watt speaker, you're filtering 100 watts of audio, and you end up with fairly bulky components and generally compromises. So you're not always going to have perfect filtering. So you're going to end up with some mid-range in the woofer and some low end in the mid-range and so on. You're going to have phase shifts. It's just one big compromise basically. If instead you use a digital processor to split the audio up into low, mid, and high, you could then have three different analog streams you can generate, send to three different power amplifiers that can each drive the drivers in the speaker cabinet without needing the separate crossover network. And what that means is, firstly, because you have different amplifiers driving each driver, you have separate. There's no interaction basically. That one amplifier is only amplifying the bass. So you could have a 200-watt bass amplifier and you'd have heaps of bass. It would never have to amplify anything other than bass. And also the fact that you're doing this digitally means that you can tweak exactly the properties that you want in terms of where the crossover occurs, what frequencies go to the woofer, how steep the roll off is, all that sort of thing. You can basically make it mathematically perfect so that you know that the sound coming out of the speaker when it combines again is exactly what you had going in the first place. So this chip can do that. It's a DSP, it can do all the filtering, you can set it up, the software is designed for that. So that's why we have multiple audio outputs, and you can send them to different amplifiers, to different drivers, and set this software up to split it the way that you want it to be split. So that means you don't need a separate active crossover, you don't need passive crossovers. All you need is this preamp, some power amplifiers, and some drivers in a box, and you can tweak it until it's perfect. So it's a very powerful system. This chip runs at, I think, a few hundred megahertz. It's a dedicated DSP, which means it's very good at doing the sort of calculations that you need for these filters, which is basically lots of multiplications and additions. And it also can route the data. So we have the ADC data going in. This is a USB audio device, so you can feed it in data via USB. So there's in fact in and out for the USB, so you can also feed it back to the computer. And then we have these three DACs, digital to analog converters. So this is the 6 channels of output that you can set up to be low, mid, and high, or you could just have them be filtered differently if you want. If you want to drive, you could have 2 go to subwoofers and 2 go to full range speakers. You could have them go to speakers in different rooms, whatever you want. It's digital, so you can set it up and control it. Here's the USB interface. Here's the microcontroller that provides the front end, so drives the screen, handles button presses, that sort of thing, configures the DSP. But the DSP is what's doing all of the actual work. So that was published in the October issue. Now, if we have a look at this article, this is coming up in the November issue. It will be published later this month and available for sale in newsagents, and it will be delivered to subscribers and available on our website. So this part 2 deals with basically building the the internals of the digital preamp. So here we have the power supply board. This takes the output of a transformer and produces the voltages we need, which is basically 5 volts and then plus and minus 10 volts that runs most of the analog circuitry. And then here we have the main board. This also has onboard power supply circuitry over here. So it takes the plus and minus 10 and it generates a bunch of different rails that are needed for all this other circuitry. And you can see that it's an interesting board. It's a 4-layer board. We're only showing 2 of the layers because we're not showing the power planes that will just obscure everything. But we have a mix of surface mount and through-hole parts. It's designed to be straightforward to assemble by hand. Even though these are relatively fine pitch chips, they're not too difficult to solder, and normally you would just put these surface mount stuff on first and then move on to the through hole. And the majority of components are through hole, so they're easy. You just push them in and solder the leads and trim them. Obviously, we have a bunch of op amps over here in the analog section, some relays for switching. These are the DAC chips. Yes, here's the ADC, IC9. Here's the control circuitry. So it's broken down into sections nicely. They're even labeled. So you can see what they do. Here's the input switching, digital I/O, the USB interface. So relatively straightforward board to build. It would probably take you a couple of days to put everything on here by hand. In the end, you'll have a very nice, very powerful preamp. Here's a photo of the assembled board. And you can see that the USB interface attaches by these connectors here that are on flying leads. These come with the interface. So you buy the interface, you solder these wires to the board, and then the USB interface just sits here and you plug that in. And then there are also 2 options for the DSP. Here we have the DSP is soldered directly to the board with the supporting components around it. So everything is on this board except for the USB interface. But you also have the option, I believe you can see it in one of these photos. I think it actually was over here. You can see here there's a carrier board. So you can buy this board with the components already on it, solder some sockets onto the board and just plug it in like a module. That saves you having to deal with that chip and its support components. So it's up to you. It's cheaper and neater if you put it on the board, but it's definitely extra work. So if you don't want to deal with that hassle, you just whack the sockets in there and plug it in. Here's some details about connecting the LCD screen, which is a pretty simple character LCD. The front panel controls just some buttons and a rotary encoder and an infrared receiver for the remote control. Here's the list of parts, which is substantial, but actually quite, when you think about it, quite modest given the complexity of this design. There's some extra parts over it. The power supply and stuff is on the side, where in the middle we have the main parts of the main board. This circuit board, we can supply that board plus the front panel and the power supply board, and everything else you have to source yourself. A lot of it can be bought from DigiKill Mouser, so if you don't want to have to run around to lots of different retailers, that's probably your best option. So this construction article has some hints on soldering the chip, which is a little bit tricky because the leads don't actually stick out, but luckily the pads in the board are quite long, so it's easy enough to make fillets despite that. And there's some information on testing. It's a very step-by-step process of putting it together because there are so many sections to populate, and he's given you a hint as to which order is best to do it so that you can test it in stages, which I think is very important for a board of this complexity. You wouldn't want to solder everything onto the board, apply power, it doesn't work, and then you have no clue what's going on. If you do it in sections, you can test, say, the microcontroller, make sure everything is working before you move on to anything else, which is a great idea. So that's the digital preamp. There will be a third part in the December issue that has to do with the case, drilling the case. There are quite a few holes to make in the back, for example. You can see all those sockets there that need to have holes in the back, so we have templates and measurements for that, and some more information about wiring everything up. There's some mains wiring, so that has to be done properly. It's safe if it's done properly. You can see there's a partition there so that the mains input and going to the switch and then the transformer is completely separate from all the low voltage stuff over here. And there's a grommet here. The wires go through there, so there's no possibility of any high voltages making their way through the low voltage section. So all that will be in the December issue. So I hope you found that interesting, and if you want to build this, then please check out the October, November, and December 2025 issues of Silicon Chip magazine. Thank you.